Hello students, we are learning 11th standard physics. The name of the chapter is thermal properties of matter. Here we are going to learn about thermal expansion. Thermal, this is term related with heat, and expansion, it means increase in dimension. Thermal expansion means increase in dimension due to heat. In our day-to-day life, we always use the words heat and temperature. Let us understand what is heat and what is temperature. What you see here is a cup of tea, which is very hot. Suppose the temperature T1 is greater than T2, then the body with higher temperature T1 is said hot body, and the body with lower temperature T2 is said cold body. After some time, what you found? The temperature of both bodies same, that is T. So what happened here is the heat flow from the body at higher temperature to the body at lower temperature. Let us understand what is temperature. So temperature is the thermal state or condition that determines the direction of heat flow, and temperature is average energy of the particles. टेम्परेचर काय आहे तर एखाद्या बॉडीचं थर्मल स्टेट सांगते. त्याच्यावरून काय समजतं तर फ्रॉम वेअर द हीट फ्लोज टू वेअर, म्हणजे डायरेक्शन ऑफ द हीट फ्लो. आपल्याला माहिती आहे की आपण म्हणतो द बॉडी at higher temperature is hot, the body at lower temperature is cold, and the heat flows from hot body to cold body. So what is temperature? Temperature is also average energy of the particles of the body. Body particles पासून बनलेली असते. So what is temperature? It is a degree of hotness. Temperature is a degree of hotness. Temperature is measured in 3 different units: Celsius, Fahrenheit, and Kelvin. What is heat? So heat is the energy in transit, or we can say heat is the energy transferred from body at higher temperature to the body at lower temperature. That is, flow of heat is always from higher temperature to the lower temperature, and heat is the total energy of the particles. Now, very important, temperature is indicating what average energy of the particle, and heat is the total energy of the particle. Now, temperature is what degree of hotness, while heat is the quantity of hotness. What are the units of heat? Joule and calories. How to measure the temperature? Let us learn measurement of temperature. The science of temperature and its measurement is called as thermometry. Thermometry means what? Metry means measurement, thermo means heat. So the science of measurement of the heat, and you know that heat is measured in terms of temperature because temperature is a degree of hotness. So the science of temperature and its measurement is called thermometry. The instrument designed to measure the temperature is called as thermometer. आपण लहान असतापासूनच थर्मोमीटर हा शब्द ऐकलेला आहे. थर्मोमीटरचं कामच काय तर टेम्परेचर मेजरमेंट करणं. ह्याच्यामध्ये थर्मो या शब्दाचा अर्थ असतो हीट, किंवा आपण वॉर्म म्हणू. आता हिवाळ्याचे दिवस आहेत तर तुम्ही थर्मोवेअर्स वापरता, बरोबर आहे की नाही. तुम्हाला थंडी वाजते म्हणून. Meter means measure, means the thermometer is used to measure the hotness, that's warmness. Now the instrument to measure temperature is called thermometer. There are different types of thermometers. First, liquid in glass thermometer. Okay. So when we use the liquid in glass thermometer, here the pressure remains constant and we measure change in temperature with respect to change in volume. कारण प्रेशर कॉन्स्टंट ठेवल्यानंतर टेम्परेचर आणि व्हॉल्यूम हे डायरेक्टली प्रोपोर्शनल असतात. लिक्विड इन ग्लास थर्मोमीटर म्हणजे मर्क्युरी इन ग्लास किंवा अल्कोहोल इन ग्लास असतं. तुम्ही थर्मोमीटर बघितलं असेल तर जसं जसं टेम्परेचर वाढतं तसं हा मर्क्युरी किंवा अल्कोहोल काय होतो, एक्सपांड होतो, म्हणजे त्याचा व्हॉल्यूम वाढतो. ओके. आणि इन्क्रीज इन व्हॉल्यूम हे आपण थर्मोमीटर कॅलिब्रेट केलेला असतो. त्या कॅलिब्रेशन वरून आपण इन्क्रीज इन व्हॉल्यूम बघत असतो, पण ऍक्च्युअली कॅलिब्रेशन सांगतं इन्क्रीज इन टेम्परेचर. Next type of thermometer is a constant volume gas thermometer. Volume remains constant. When the volume is constant, then temperature is directly proportional to pressure. Okay. So actually what we observe is a change in pressure, but what is calibrated is increase in temperature or change in temperature. Then there are resistance thermometers. Those are also called as thermistors. Okay. In that, actually we measure the change in resistance and calibration is change in temperature. So delta T gives delta R. Those are also called as thermistors. Now after learning three types of thermometer, let us see what are the different scales. I just said you that there are three different units for measurement of temperature, that is Celsius, Fahrenheit and Kelvin. So there are three different scales for measurement of temperature, that is Celsius scale, Fahrenheit scale and Kelvin scale. My dear students, you must know what is ideal equation. It is PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R is called universal gas constant and T is called temperature. Dear students, pressure, volume and temperature, these are the coordinates of thermodynamic system. These are the coordinates of thermodynamic system. ज्या पद्धतीनं जॉमेट्री मध्ये आपण एक्स वाय झेड कोऑर्डिनेट्स असतात असं आपण म्हणतो, तसं प्रेशर, व्हॉल्यूम आणि टेम्परेचर या थर्मोडायनामिक सिस्टीमचे कोऑर्डिनेट्स असतात. T pressure, V volume, T temperature, N means number of moles and R means ideal gas constant. So here the number of moles for thermodynamic observation remains constant. The ideal gas constant is also constant. So what is the variation between pressure, volume and temperature we observe here? So PV upon T is equal to constant, that is equal to N into R, plus number of moles constant and ideal gas constant is okay, universal gas constant R is also constant. So PV upon T is equal to constant. So we get here P1 V1 upon T1 is equal to P2 V2 upon T2. So we observed here the ideal gas equation and we learn here how to use the ideal gas equation. P1 V1 upon T1 is equal to P2 V2 upon T2. As we discussed before, there are three different scales for measurement of temperature: Celsius scale, Fahrenheit scale, and Kelvin scale. Now, which scale is mostly used? That is Kelvin scale. That is also called as absolute temperature scale. Now, all these scales are linear, and here one linear equation is written here, that is y is equal to mx plus c and y is equal to mx. Now, what is this? Do you know that at constant pressure, volume is directly proportional to temperature, that is change in volume directly proportional to change in temperature. So we get V upon T is equal to constant. So this is the x-axis. On x-axis we are indicating temperature and y-axis we are indicating volume. say the pressure is constant. Now for a particular gas A, what we observe here, that is when it cuts the y-axis, okay, so we are getting temperature at 0 degrees Celsius, but volume is not 0. For gas B also, temperature is 0 degrees Celsius, but volume is not 0. And for gas C also, temperature is 0, but volume is not 0. Means this 0 degrees Celsius, at 0 degrees Celsius temperature, we are not getting the volume of the gas as 0. What we know here is that at constant pressure, the volume is directly proportional to temperature. Now, if the temperature is 0 degrees Celsius, we expect that the volume should also 0. But volume is not 0. Means this temperature 0 degrees Celsius is not actually 0. Now, what is done here? So, we are extending this graph towards the negative x-axis, and what we found is that for gas A, the volume is 0. For gas B, also the volume is 0. And for gas C, the volume is 0. But the temperature is not 0. It is a negative temperature. And what we observe here, it is a negative 273.15 degrees Celsius. And that is called as 0 Kelvin. विद्यार्थी मित्रांनो, इथं तुमच्या एक लक्षात घ्या की जसं जसं टेम्परेचर वाढतंय तसं तसं व्हॉल्यूम वाढतोय जेव्हा प्रेशर कॉन्स्टंट असतो तेव्हा. मग टेम्परेचर कमी झालं तर व्हॉल्यूम पण कमी झाला पाहिजे. तिथं टेम्परेचर कमी करून आपण 0 डिग्री सेल्सिअस करतोय, पण त्यावेळेला व्हॉल्यूम शून्य होत नाही. मग जेव्हा तुम्ही व्हॉल्यूम शून्य करायचं ठरवलं तेव्हा मात्र काय घडलं, तर मागे जाऊन तुम्हाला एकच पॉईंट असा मिळाला की तिथं व्हॉल्यूम शून्य झालाय. गॅस ए चा पण व्हॉल्यूम शून्य आहे, गॅस बी चा पण व्हॉल्यूम शून्य आहे, गॅस सी चा पण व्हॉल्यूम शून्य आहे, पण टेम्परेचर मात्र तिथं झालेलं आहे -273.15 डिग्री सेल्सिअस किंवा 0 केल्विन. Now let us compare the three scales, that is absolute scale, that is Kelvin scale, Celsius scale, and Fahrenheit scale. So there is one formula: unknown temperature on the scale minus ice point upon steam point minus ice point. Notice what is ice point. For ice point, we say the temperature is 0 degrees Celsius, and for steam point, we say the temperature is 100 degrees Celsius. And what is this unknown temperature on the scale that we are going to measure? So what happens here? For Celsius scale, you have to write Tc minus 0 upon 100 minus 0, because Tc is the unknown temperature in Celsius, minus 0, that is the ice point, that is 0 degrees Celsius, 100, that is steam point, or you can say boiling point of water, that is 100 degrees Celsius, and minus again steam ice point, that is 0 degrees Celsius. Now Kelvin scale. For Kelvin scale, the temperature, unknown temperature Tk, that is temperature in Kelvin, minus what is the ice point here? The ice point is 273.15. And what is the steam point? It is 273.15 plus 100, that is 373.15, minus again ice point. Now what about the Fahrenheit? In Fahrenheit, the temperature is in Fahrenheit minus 32 divided by 212 minus 32. So here we get Tc minus 0 upon 100. Then this is Tk minus 273.15 upon 100. And here Tf minus 32 upon 180. Now if we compare these three scales, that is a Kelvin scale, Celsius scale, and Fahrenheit temperature scale. First is Kelvin scale, then Celsius scale, and Fahrenheit scale. Water boils, or that is also called as steam point. For Kelvin, it is 373.15. For Celsius, it is 100 degrees Celsius. But for Fahrenheit, it is 212. Okay. Now, body temperature of the human being, that is 37 degrees Celsius. It is 98.6 Fahrenheit, and it is 310.15 Kelvin. Water freezes, that is at 0 degrees Celsius. So for Celsius, it is 0 degrees Celsius. For Kelvin, it is 273.15. 15, and for Fahrenheit it is 32 Fahrenheit. What is absolute zero temperature? So absolute zero temperature is a temperature, the reading for Kelvin is 0. For Celsius it is minus 273.15, and for Fahrenheit it is minus 459.60. विद्यार्थी मित्रांनो, हे स्केल काढत असताना तुमचे हे टेम्परेचरचे जे थर्मामीटर दाखवले त्यांच्या हाईट सेम दाखवा. काही जण हाईट सेम दाखवत नाही. Numericals on measurement of temperature. If the temperature in a room is 20 degrees Celsius, what is its temperature in degree Fahrenheit? एका रूमचं टेम्परेचर 20 डिग्री सेल्सिअस दिलेलं आहे, तर मग त्याच रूमचं टेम्परेचर डिग्री फॅरनहाइट मध्ये किती असेल? खूप सोपं आहे. आत्ताच तुम्ही स्केल्स बघितले होते. सेल्सिअस मध्ये 20 डिग्री सेल्सिअस आहे, फॅरनहाइट मध्ये किती हा प्रश्न विचारलाय. तर टीसी म्हणजे अननोन टेम्परेचर इन सेल्सिअस मायनस आइस पॉइंट दॅट इज 0 divided by 100 is equal to TF, that is unknown temperature in Fahrenheit, minus 32, कारण फॅरनहाइट मधला आइस पॉइंट 32 आहे आणि फॅरनहाइट मध्ये आपण डिग्रीज किती केल्या होत्या, 1 म्हणजे डिव्हिजन्स किती केल्या, 180 केल्या होत्या. हा फॉर्म्युला आहे. मग या फॉर्म्युल्यामध्ये दिलेल्या किमती वापरा. तुम्हाला टेम्परेचर इन सेल्सिअस दिले 20 डिग्री सेल्सिअस, सो पुट दॅट 20 minus 0 upon 100 is equal to Fahrenheit, that is TF minus 32 upon 180. Now 180 into 20, that is equal to 360 divided by 100 is equal to TF minus 32. So TF is equal to 3600 upon 100, that is 36, and this 32 is added there, so that is plus 32, and that will come what? That will come 68. Change करून घ्या, 68 Fahrenheit. The normal boiling point of liquid oxygen is minus 183 degrees Celsius. What is this temperature in Kelvin scale? ऑक्सिजन साठीचा बॉइलिंग पॉइंट, लिक्विड ऑक्सिजनचा बॉइलिंग पॉइंट हा minus 183 डिग्री सेल्सिअस आहे. तर केल्विन मध्ये किती असेल? सोपं आहे. You are given the temperature in degree Celsius, you are asked the temperature in Kelvin. Again, this is the formula: Tc minus 0 upon 100 is equal to Tk minus 273.15 minus 100. So Tc minus 0 upon 100 is equal to Tk minus 273.15. Tc is what? Minus 183 minus 0 upon 100 is equal to Tk minus 273.15 upon 100. 100 get cancelled. So what we get here is a Tk is equal to this minus 273.15 is positive and this is negative minus 183. So Tk is equal to 90.15 K. At what temperature do the Kelvin and Fahrenheit scale coincide? मस्त प्रश्न आहे. असं कोणतं टेम्परेचर आहे की तिथे केल्विन आणि फॅरनहाइट यांच्या व्हॅल्यू कोइन्साइड होते? फाइंड दिस. x is equal to question mark when tf is equal to tk. आपण आता काय केलं, tf minus 32 upon 180 is equal to tk minus 273.15 upon 100 हा आपला फॉर्म्युला लिहून टाकला. Let the required temperature be x, okay, tf, and that is equal to tk. So tf minus 32 upon 180 is equal to tk minus 273 upon 15. So value used is tk is equal to tf, that is equal to x. So it is x minus 32 upon 180 is equal to x minus 273.15 upon 100. So this will be 5x minus 60 is equal to 9x minus 2458.35. So we get here the value of x is 573.6 Kelvin, and that is equal to 574.6 Kelvin, and that is equal to 574.6 Fahrenheit also. Now let us think about the linear expansion. You know, my dear students, a geometrical shape, say cube, there is a length, breadth, and height. But for a metal rod, the length is more than the cross-sectional area. So let us consider a long uniform metal rod of the isotropic solid. आता इथं आयसोट्रॉपिक हा एक शब्द आलाय. आपण लेक्चरच्या वेळी आपण डिस्कस केलं होतं की आयसोट्रॉपिक आणि अनआयसोट्रॉपिक म्हणजे काय असतं. तर आयसोट्रॉपिक सॉलिड अशा सॉलिडला म्हणतात की जे एक्सपान्शन करताना ज्याचं थर्मल एक्सपान्शन होताना इक्वल इन ऑल डायरेक्शन होते. ओके, इक्वल इन ऑल डायरेक्शन जर एक्सपान्शन झालं तर त्याला आयसोट्रॉपिक सॉलिड म्हणायचं. आणि जर डिफरंट डायरेक्शन मध्ये डिफरंट एक्सपान्शन झालं तर त्याला अनआयसोट्रॉपिक एक्सपान्शन म्हणायचं. त्या सॉलिडला अनआयसोट्रॉपिक सॉलिड म्हणायचं. आता इथं आपण बघूया, कन्सिडर लॉंग युनिफॉर्म मेटल रॉड ऑफ अन आयसोट्रॉपिक सॉलिड. आपण इथे आयसोट्रॉपिक सॉलिडचा हा लॉंग रॉड बघितला. ओके, आणि त्याचं काय केलं, हिटिंग केलं. तर हिटिंग केल्यानंतर काय होणार आहे, ऑब्विसली ते एक्सपांड होणार आहे. एक्सपांड होणार म्हणजे त्याची लेंथ काय होणार आहे, वाढणार आहे. येस, देर इज इन्क्रीज इन द लेंथ. आता तुम्ही इथे दोन फिगर बघता, त्यामध्ये जो ओरिजिनल रॉड आहे तो वर आहे आणि खाली हा रॉड काय झालाय, एक्सपांड झालेला आहे. तो ओरिजिनल लेंथ is L original, or you can call it as L0. Okay, and you can think that this length is measured at temperature 0 degree Celsius. Now after heating, the temperature rises to T degree Celsius, and in that duration the length become LT. What is the increase in length? That is LT minus L0, and this increase in length is called as a linear expansion. So increase in the length of the rod is directly proportional to its original length L0 and rise in temperature T. आता बघा लक्षात घ्या की इन्क्रीज इन लेंथ म्हणजे एक्सपान्शन काय तर LT मायनस L0 आहे, आणि इन्क्रीज इन लेंथ आहे ती ओरिजिनल लेंथशी डायरेक्टली प्रोपोर्शनल असते. त्याचबरोबर जो टेम्परेचर राईज झालाय त्याच्याशी सुद्धा ती डायरेक्टली प्रोपोर्शनल असते. So LT minus L0 directly proportional to L0, LT minus L0 directly proportional to T. So together we can write LT minus L0 directly proportional to L0 into T. LT minus L0 is equal to alpha into L0 T. बघा पहिलं जे इक्वेशन आहे त्याच्यामध्ये आपण हे जे हे आहे हे डायरेक्टली प्रोपोर्शनलचं साइन आहे, आणि इथं हा अल्फा हा कोएफिशियंट आहे. मग ह्याला म्हटलं जातं, येस, इट इज कॉल्ड एज व्हॉट, लिनियर कोएफिशियंट ऑफ थर्मल एक्सपान्शन. काय म्हटलं जातं, लिनियर कोएफिशियंट ऑफ थर्मल एक्सपान्शन. अल्फा इज कॉल्ड एज अ कोएफिशियंट ऑफ लिनियर थर्मल एक्सपान्शन, किंवा लिनियर कोएफिशियंट ऑफ थर्मल एक्सपान्शन, कोएफिशियंट ऑफ लिनियर एक्सपान्शन, coefficient of linear thermal expansion of solid. So what is alpha? It is LT minus L0 upon L0 T. Okay. So suppose L0 is equal to 1 at 0 degree Celsius. Okay. And after increasing the temperature, say 1 degree Celsius, after increasing the temperature, say 1 degree Celsius, its length is LT. So LT minus L0 divided by L0, it is 1, and temperature increase also 1 degree Celsius. So alpha is equal to LT minus L0 when yes, the original length is unit, that is 1, and the increase in temperature also unit, that is 1. So we can define what is the coefficient of linear expansion of a solid. So coefficient of linear expansion of solid is defined as, yes, it is the increase in length per unit, कारण length आपण unit घेत आहोत, ओरिजिनल लेंथ ऍट 0 डिग्री सेल्सिअस, आणि राइज इन टेम्परेचर आपण युनिटच घेतला होता, त्यामुळे पर डिग्री राइज इन टेम्परेचर. डिअर स्टुडंट्स, ही डेफिनेशन तुम्हाला पाठ पाहिजे. कोएफिशियंट ऑफ लिनियर एक्सपान्शन ऑफ अ सॉलिड इज डिफाइंड एज इंक्रीजिंग द लेंथ per unit original length at 0 degree Celsius per degree rise in temperature. Now what is the unit for this alpha? So very easy. The increase in length is measured in meter. Now this is divided by meter. So meter get cancelled. Again this is divided by temperature. So it will be per degree Celsius, or it may be per degree Kelvin. So unit काय असेल बरं, coefficient of linear expansion चा per degree Celsius or per Kelvin. Now the value of alpha depends upon the nature of the material. The magnitude of the coefficient of linear expansion is very small, so it is not necessary that initial temperature be taken at 0 degree Celsius. आता टेम्परेचर कोएफिशियंटची जी व्हॅल्यू आहे ती खूपच छोटी येते, आणि आपण आता इथं काय बघितलं तर ओरिजिनल लेंथ जी तुम्ही मोजली ती 0 डिग्री सेल्सिअसला मोजली. तर प्रॅक्टिकली प्रत्येक वेळेला आपण 0 डिग्री सेल्सिअसला जाऊन टेम्परेचर मोजू शकत नाही. म्हणून आपण काय करूया, अजून एक एक्सप्रेशन काढूया. ठीक आहे, आता समजून चला की इनिशियल टेम्परेचर आहे T1 डिग्री सेल्सिअस आणि लेंथ आहे L1. So L1 is the length of the rod at T1 degree Celsius. Now again that there is change in temperature, that is T2 degree Celsius, and the length, that is expansion. After expansion the length is L2. So L1 is the length of the rod at T1 degree Celsius, L2 is the length of the rod at T2 degree Celsius. Now obviously here T2 is greater than T1. So As we know that LT minus L0 is equal to alpha into L0T. So LT is equal to L0. Okay, see here, this minus L0 comes here as a plus L0 and L0 is taken common. So LT is equal to L0 into the bracket 1 plus alpha T. Now similarly, L1 is equal to L0 into the bracket 1 plus alpha T1 and L2 is equal to again L0 into the bracket 1 plus alpha T2. Now what we do, we take, yes, dividing we get, that is L2 divided by L1, L0 get cancel. What we get here is 1 plus alpha T2 upon 1 plus alpha T1. Okay. Now this 1 plus alpha T1, it is divided by, so it is multiplied by with the power minus 1. Now by binomial expansion, 1 plus alpha T1 raised to minus 1, we get 1 minus alpha T1. minus 2 alpha square T1 square. मॅथ्स मध्ये आपण जेव्हा बायनॉमियल एक्सपान्शन चॅप्टर शिकू तेव्हा ह्या गोष्टी आपल्याला कळतील. सो अल्फा इज अ व्हेरी स्मॉल, कारण स्क्वेअरिंग झाल्यानंतर अल्फा ही खूप छोटी व्हॅल्यू आहे आणि त्याचं स्क्वेअर म्हटलं तर आणखी खूप छोटी व्हॅल्यू होईल. त्यामुळे त्यांना आपण काय करून टाकायचं, सरळ सरळ त्या अल्फा असणाऱ्या हायर ऑर्डरच्या टर्म्स निग्लेक्ट करून टाकायच्या. त्यामुळे L2 upon L1 is equal to 1 plus alpha T2 into 1 minus alpha T1. Okay. Now L2 upon L1 is equal to 1 into 1, that is minus alpha T1 plus alpha T2 and then minus alpha square T1 T2. Again this term is cancelled. So neglecting alpha square T1 T2. So L2 upon L1 is equal to 1 plus alpha into the bracket T2 minus T1. So what is L2? So L2 is a L1 into the bracket 1 plus alpha into the bracket T2 minus T1. So L2 minus L1 is equal to L1 alpha into the bracket T2 minus T1. So again alpha is L2 minus L1 upon L1 into T2 minus T1. So what we get here is another formula for coefficient of linear expansion. That is L2. It is what? It is a L2 minus L1, that is increase in length, divided by what? Original length L1 and yes, increase in temperature. So we get the practical formula. Now let us think about areal expansion. So areal expansion means what? Expansion in area. Actually solid is isotropic. त्यामुळे लेंथ वाढते, त्यामुळे ब्रेड सुद्धा वाढते, त्यामुळे एरिया सुद्धा वाढणारच आहे, कारण एरिया म्हणजे लेंथ इंटू ब्रेड असतो. So consider a thin uniform plate of an isotropic solid having each side of length L0 at 0 degree Celsius. प्रत्येक साइडची लेंथ L0 आहे at 0 degree Celsius. When the solid metal plate is heated, obviously it will expand. The metal plate expand will. Surface area increases. Okay, and this is called superficial expansion. Okay. Surface area of one side of the plate at 0 degree Celsius, that will be A0 is equal to L0 square. Now after rise in temperature or after expansion, the length of the plate becomes LT. So the surface area of the plate at T degree Celsius, that will be AT, will be LT square. What is the increase in the surface area? That is AT minus A0, that is equal to LT square minus L0 square. So increase in area of the plate is directly proportional to the original surface area A0 and rise in temperature T. हे फार महत्त्वाचं लक्षात ठेवायचं. जसं मगाशी आपण बघितलं होतं की increase in area काय होता, तर डायरेक्टली प्रोपोर्शनल होता. कुणाशी? ओरिजिनल लेंथशी. आणि कुणाशी? राइज इन टेम्परेचर. तसं अगदी increase in area of the plate is directly proportional to original surface area A0 and rise in temperature T. Now AT minus A0 directly proportional to A0T. AT minus A0 is equal to beta into A0T. Here beta is a proportionality constant. Beta is a proportionality constant. So areal expansion, here we get the beta, coefficient of areal expansion of solid, or you can say thermal coefficient for areal expansion of solid. So AT minus A0 is equal to beta into A0T. So beta is equal to AT minus A0 upon A0T. Now if we suppose the initial area A0 is 1 and initially the increase in temperature is just 1 degree Celsius, then beta is what? It is increase in area per unit area per degree rise in temperature. So coefficient of areal expansion of solid is defined as increase in area per into original area at 0 degree Celsius per degree rise in temperature. Now again we have to think practically. So what is the unit for this beta? That is again per degree Celsius or per Kelvin. So let the value of beta depends upon the nature of the material. Yes, the magnitude of the areal expansion is very small, so it is not necessary that initial temperature to be taken at 0 degree Celsius. म्हणजे प्रत्येक वेळा आपल्याला 0 degree Celsius टेम्परेचर घेऊनच काम करावं लागेल असं काही नाही. प्रॅक्टिकली आपण वेगळ्या पद्धतीने विचार करू शकतो. So coefficient of areal expansion. So for this, let us consider the area is A1, yes, of the rectangular metal frame, or you can say square also at T1 degree Celsius. And again, after heating, it is expanded. Okay, the increase in temperature to the last temperature 2 degrees Celsius, and in area of the frame is now A2. Okay, so as T2 is greater than T1, AT minus A0 is equal to beta into A0T, and AT is equal to A0. That is, this minus A0 comes to this side, and A0 is taken in common. So A2 is equal to A0 into the bracket 1 plus beta T. Now A1 is equal to A0 to the bracket 1 plus beta T1, and A2 is equal to A0 into the bracket 1 plus beta into T2. So A1 upon A2 upon A1 is equal to A0 into the bracket 1 plus beta T2 upon A0 into the bracket 1 plus beta T1. So A2 upon A1 is equal to A0 get cancelled, 1 plus beta T2 into 1 plus beta T1 raised to minus 1. By binomial expansion, 1 plus beta into T1 raised to minus 1, that is equal to 1 minus beta T1 plus 2 beta square T1 square, and so on. But beta is a very small, so order is minus 10 raised to minus 6. So higher powers of beta squares are neglected. So we write here A2 on A1 is equal to 1 plus beta into T2 in 1 into 1 minus beta T1. So A2 upon A1 is equal to 1 minus beta T1 plus beta T2 minus beta square T1 T2. Now beta square, that is higher orders, are neglected. So A2 upon A1 is equal to 1 plus beta is taken common into the bracket T2 minus T1. A2 is equal to A1 multiplied there into the bracket 1 plus beta T2 minus T1. Again, A2 minus A1 is equal to A1 beta T2 minus T1. So beta is what? So beta is A2 minus A1 upon A1 into T2 minus T1. Means the coefficient of areal expansion is increase in area per into original area divided by increase in temperature. This is a practical formula.